Hello and welcome to another video of Wise Interactive Learning. In this video, as we have learned all the concepts regarding differentiation and different types of differentiation, in this video we are majorly going to see the exercise from CBSE and which is 5.2 exercise, and we are not going to do each and every step, rather we are going to do directly answers towards the answers, and we are going to make sure that we have cleared our concepts and we can do them in a faster way. So let's take the first question, which says that sine of x square plus 5 and we have to differentiate it. So when y equals to sine of x square plus 5, we know that here we have to use the chain rule. So immediately you know that y dash is equals to cos of x square plus 5 times, you have to differentiate x square plus 5 again since it is the inside function, or we also have called this as a box rule. If you want to find out how this is done, you can check the video in the description or in the I button. So again, when you differentiate x square plus 5, you get 2x. So your final answer is cos of x square plus 5 times 2x. So we'll take the second question. Second question says y equals to cos of sine of x. So it's very easy. You immediately know y dash will be minus of sine x times the differentiation of sine x, which is cos of x. So this is your final answer. We'll take the third question. So in the third question we have y equals to sine of ax plus b. These are very easy examples, so I'm just going to speed run through all answers, and we're going to make sure that we have cleared the concepts in 5.2, 5.3, 5.4 up until 5.6. So y dash will be differentiation of sine, which is cos of whatever the function it is, which is ax plus b, times you have to differentiate ax plus b. So since ax differentiated will be a and b is a constant, so it's 0. So your final answer will be a times cos of ax plus b. So this is your final answer. So we are going to see now fourth question. So the fourth question is y equals to sec of tan of, so the first function is of sec, second is of tan, and the inside function, the innermost function, is root of x. So when you are differentiating sec of x, you are going to have sec the inside function, which is tan of root x, times tan of the inside function, which is again tan of root x. So be careful in this terminology. Again, you have to multiply it by the inside function's derivative. So tan's differentiation will be sec square x, so it is going to be sec square the inside function, or the root x. Now we know that we have went inside two times, so we have first taken the differentiation of sec, then we have taken tan, now we have to take the derivative of root x, which is 1 upon 2 root x. So this is your final answer, which is sec times tan of root x times tan of root x times sec square root x, everything divided by 2 root x. So for the fifth question, we are going to use logarithmic differentiation. So in this case, we are going to take log on the both sides. So we have log y, and here we have log of sine of ax plus b, and since it's in the denominator, we are going to have a negative sign, and again we have log of cos of cx plus d. So make sure that in the sine terminology you have ax plus b, and in the cos terminology you have cx plus d. So don't jumble it by writing ax plus b on the same terms. Now we just need to differentiate it. So we know that differentiation of log of any f of x, it is 1 upon f of x, which is 1 upon y, times dy upon dx. And now you just need to differentiate these functions. So log of sine ax plus b differentiation will be 1 upon sine of ax plus b, but we need to again differentiate sine x, which is cos of ax plus b. Then again you have to go inside and you have to differentiate ax plus b, which comes out to be only a. In the same case, you can say that this whole function is going to be minus sine of cx plus d times c whole divided by cos of cx plus d. And how we have directly got to this answer? It is very easy. So if you see in the first term, whatever the inside of log function was, it came in the denominator. Then we have the differentiation of sine over here, and then we have the coefficient of x here. So similarly, differentiation of cos, we have minus of sine, then coefficient of x we have c over here, and then the whole term which is inside the log comes into the denominator. So we can simplify this by saying that, so here you can see that it is cos upon sine of ax plus b, so it becomes cot ax plus b, which is a times, and you have a negative sign over here and another negative sign over here, so you have positive sign plus c times tan of cx plus d. So this is our not final answer. Why? Because on the left hand side we clearly don't have only dy upon dx. What do we have an extra is 1 upon y. So when you multiply y on the both sides, you can have your final answer, which can be also written as dy upon dx, which is going to be sine of ax plus b upon cos of cx plus d times a cot of ax plus b plus c times tan of cx plus d. So that's your final answer. So without further ado, we are going to solve this sixth question, which is cos of x cube times sine square x raised to 5. So you don't get jumble over here since we have different complex functions. Well, what we can do is we can take these terms as different. So we can take cos of x cube as different, and we can take sine square x raised to 5 as different. And since we have a product rule which we can use easily, you can solve this example within no time. So the answer to this will be, if you take this as u and this as v, your answer is going to be y dash equals to u v dash plus v u dash. This is a very simple basic product rule, and you know that since u equals to cos of x cube, u dash will be minus sine of x cube times 3x square, right? And v dash will be 2 sine of x raised to 5. Be careful that it is not sine raised to 5. So the next function is sine, so you can take it as cos of x raised to 5 times 5 times x raised to 4. And this is a basic rule which we call it as chain rule. And finally we have our answer as y dash equals to u times v dash. So u is cos of x cube times v dash is this term, so it is going to be 2 times sine of x raised to 5 cos of x raised to 5 times 5x raised to 4. So you can simplify this further, plus you have v times, so v is nothing but sine square x raised to 5, isn't it? So v times u dash. What is u dash? It is negative of sine of x cube times 3 times x square. So you can simplify this further, and you can say that your final answer is 10x raised to 4 and cos of x cube sine of x raised to 5 times cos of x raised to 5. You can further simplify this, but we are not going to do it. We are just simply going to leave it as it is, negative, which is minus sign. So sine square x raised to 5 sine of x cube 3x squared. So this is your final answer. Let's roll for the seventh question, which states that y equals to 2 under root of cot of x squared. Now, a common mistake people try to do over here is they'll just try to cut off x squared and this root, and they try to directly write 2 of cot of x. You getting my point? So they try to cancel off this squared and this root just by cancelling, looking at this function. But what I would like to tell you this is x squared is your theta, which is the angle, right? And you cannot cancel away the angle directly from the function. If it was cot square x under root, then you can easily could have cancelled out. But a common mistake students try to do over here is cot of x squared, they think it as square of the function and they try to cancel. So it's an easy question, we'll try to do it in a faster way. So when you try to differentiate any function which is under root, you know that its differentiation is nothing but f dash of x upon 2 root of f of x. So the same functions come down and you have the differentiation in the numerator with 2 in the denominator. So similarly, if we take f of x as cot of x square in the 7th question of ours, you can have that 2 everything divided by 2 root of cot of x square, and then differentiation of cot x is nothing but minus of cosec square x, cosec square of x square, and then you have a differentiation of x square which is nothing but 2x. So your 2 and 2 gets cancelled and your final answer should be minus 2x cosec square of x square times under root of cot of x square. So in this way you can solve the questions from 5.2 exercise very easily. Now I would like you to do me a favor by just solving this 8th question, and if you find the answer, please in the comment section write down your answer, or you can just write done in the comment section. Thanks for watching and see you in the next video for 5.3 exercise.